Hey there, beginners of AI. Welcome back to another episode of Quick Bites of AI. Today, we're diving into something that's often, well, a bit confusing when you first hear about it. And that's logistic regression. Now, before you roll your eyes or start thinking about your last awkward encounter with math, stick with me here. It's actually quite an intriguing concept once you get the hang of it. So, let's start with the basics. What exactly is logistic regression? Despite its somewhat mysterious name, logistic regression is, at its heart, a classification algorithm. Yep, you heard right. It's called regression, but it's used for classification tasks. I know. Whoever named it probably wasn't trying to make things easy on us. But bear with me, there's a good reason behind it. The regression part comes from the model being used to predict a value that gets transformed using a logistic function. This transformation outputs a probability that's used to classify data. Imagine, you're trying to predict whether someone will order dessert based on their mood. The output isn't a straight-up yes or no initially, but rather a probability. Like, there's a 60% chance they'll go for that chocolate lava cake. Chocolate. Anyway, the way logistic regression works is by modeling the probability that a given input point belongs to a certain class. You can think of it as drawing a line that best separates the classes in your data. If the data were ice cream flavors, we're essentially trying to decide, is this batch chocolate or not? This brings us to the logistic part. This refers to the logistic function, also known as the sigmoid function in math lingo. It helps by squashing the output of the linear equation into a range between 0 and 1, which is great for probabilities. Picture squeezing a slice of pizza into yes or no about pineapple toppings. Yikes. Maybe that's too real of an example for some people. Now, where would we use logistic regression? It's widely applied in situations like whether an email is spam or not, predicting elections, or even determining the likelihood of churning on your Netflix account. Because maybe, just maybe, you've finally watched everything. Let's touch on the assumptions, shall we? Logistic regression assumes that the relationship between the independent variables and the log odds of the dependent variable is linear. It's quite like assuming that your love for coffee directly increases with every Monday morning meeting. Predictable and caffeinated. Limitations. It's important to remember that logistic regression can struggle with very complex relationships because, well, it's linear. For nonlinear relationships, you might want to invite other models to the party, like my good buddy, the neural network. Keep an eye on your data, as logistic regression also doesn't handle large numbers of categorical features as smoothly as some other models. Now, before we wrap things up, here's a quick analogy for better understanding. Think of logistic regression like a gatekeeper deciding who gets into a club. The real fun begins when the probability score determines who crosses the threshold. It's that picky friend who checks out everyone's dance moves before hitting the dance floor. To sum up today's bite, logistic regression is a trusty companion for binary classification tasks, especially when relationships are as straightforward as your pasta preference on a Wednesday night. Remember, understanding the basics will pave the road for venturing into more complex AI realms. Thanks for sticking around on this journey through logistic regression on Quick Bites of AI. Keep curious, keep exploring, and as always, keep learning. Catch you all in the next episode.